We are going to discuss the minor blocks of a communication system. Previously, we discussed the major blocks of a communication system, and we know that there are three major blocks in a communication system. There is a major block for a transmitter, there is a major block for the information channel, and there is a major block for the receiver. In this topic of the course, we consider four minor blocks inside the major block of a transmitter. Then we consider the major block of the information channel, and then we consider five minor blocks inside the major block of the receiver. So there are four minor blocks inside the transmitter. There is a minor block for the message origin, a minor block for the modulator, a minor block for the carrier source, and a minor block for the coupler. We discussed the function of all these minor blocks. So let us talk about the function of the first minor block inside the transmitter, that is known as message origin. What is a message origin? It is a transducer, and we know that transducer converts the electrical signal into non-electrical signal and the non-electrical signal into electrical signal. So message origin is basically a transducer, and this transducer converts the non-electrical signal into electrical signal. Whenever we transmit information, that is signals from one place to another place with the help of a communication system, so we either transmit an audio signal or we transmit the video signal. Sometimes we transmit both the audio and video, and we transmit the data from one device to another device. We transmit data from one computer to another computer. So if we want to transmit an audio signal with the help of our communication system, microphone is the transducer in this particular case. So the message origin will be a microphone, and microphone is the example of the transducer, and this microphone will convert the sound wave into the electrical signal. It will convert the sound wave into electric current. If we want to transmit the video signal with the help of a communication system, then the transducer will be a video camera, and the video camera will convert images into electric currents. Sometimes we transmit data from one device to another device. We transmit data from one computer to another computer, and we know that data is in the electrical domain. So if you want to transmit data from one computer to another computer, we don't need a transducer at all. So message origin is basically a transducer that converts the non-electrical signal in the transmitter towards the non-electrical signal in the transmitter to an electrical signal. What is the function of a modulator? So there are two main functions of the modulator inside the transmitter. It puts the signal into a proper format and it impresses the signal onto the wave generated by the carrier source. So we can say that a modulator inside the transmitter modulates the electrical signal. And there are different types of modulation techniques. AM, that is known as amplitude modulation. FM, that is known as frequency modulation. Phase modulation. And as we are discussing the course of fiber optic communication system, so in fiber optic communication system we use intensity modulation. What is amplitude modulation? In amplitude modulation, the modulator changes the modulation of the carrier, changes the amplitude of the carrier in accordance with the variation in the modulating signal. In frequency modulation, the modulator changes the frequency of the carrier in accordance with the variation in the modulating signal. In phase modulation, the modulator changes the phase of the carrier in accordance with the variation in the modulating signal. If we consider the example of the fiber optic communication system, so we transmit signals, we transmit information with the help of light wave from one place to another place. So in fiber optic communication system, we use intensity modulation. And what is intensity modulation? Basically, we change the intensity of the light wave in accordance with the variation in the electrical signal. And this type of modulation is known as intensity modulation. In the digital communication system, we transmit bits in the form of ones and zeros, and the number of bits transmitted per second is known as data rate. So in order to generate the bits, the modulator needs to switch the carrier source on to generate 1, and it needs to switch off the carrier source to generate 0. So in case of a digital communication system, the modulator switches the carrier source on and off to generate the bits. So this is an additional function of the modulator in case of a digital communication system. We discuss the third minor block inside the transmitter, that is known as carrier source. So what is a carrier source? If we talk about the electronic communication system, so in the electronic communication system, the carrier source is an oscillator. It is an electronic oscillator. And we have studied a number of oscillators in the course of electronics. We studied Hartley oscillator, Colpit oscillator, crystal oscillator, and blah, blah, blah. And we know that this carrier source generates a very high frequency carrier. It generates a very high frequency wave. In wireless communication system, we transmit the electromagnetic signal with the help of wireless information channel from one place to another place. And the electromagnetic spectrum for the wireless communication system ranges from 3 kilohertz to 300 gigahertz. So, in case of a wireless communication system, the carrier source generate a very high frequency from this particular range. We have already discussed the range, which is from 3 kilohertz to 300 gigahertz. This will be the function of the carrier source in case of electronic communication system. In fiber optic communication system, we need to convert the electrical signal into light wave, because we transmit the information from one place to another place with the help of this light wave. And if we talk about the electromagnetic spectrum of the light wave, in case of the fiber optic communication system, so the frequency of the light wave ranges from 1.5 into 10 raised to power 14 hertz into 15 into 10 raised to power 14 hertz. So we are going to discuss the carrier source in case of the fiber optic communication system. As we have already discussed that we need to transmit the electrical signal to light signal or to light wave in case of fiber optic communication system. So this is the function of the carrier source in fiber optic communication system. And in fiber optic communication system, this is the light emitting diode or the laser diode which generates the light wave, which converts the electrical signal into light signal. And the frequency of the light signal is very high. We have already discussed the electromagnetic spectrum of the light wave. So the light emitting diode or the laser diode will convert the electrical signal into light wave, and then the light wave will travel inside the information channel. So the function of the carrier source in the fiber optic communication system is to convert the electrical signal into light wave. And this function is carried out with the help of light emitting diode or a laser diode. Now we talk about the function of the fourth minor coupler inside the transmitter, that is known as coupler. We talk about the fourth minor block inside the transmitter, that is known as coupler. The function of the coupler is to feed the signal efficiently to the information channel. As an example, I consider the wireless communication system. In the wireless communication system, the transmitter generates the message and then puts this message into a proper format. And the example of the coupler in wireless communication system is the transmitting antenna. You guys can see it in the diagram in this slide. And this transmitter, which works as a coupler, feeds the signal into the wireless information channel. So the example of the coupler in case of wireless communication system is the transmitting antenna. Well, if we consider the light emitting diode or the laser diode, which is a carrier source in the fiber optic communication system, The light emitting diode as well as the laser diode radiates the energy in the form of a cone, and this cone is known as source radiation cone. The size of the radiation cone, the size of this radiation cone is very large. If we consider the size of an optical fiber, the diameter of the optical fiber is very small. The diameter of the core of a single fiber is 125 micrometer. So this fiber will not trap all the rays of the source radiation core. Some rays will be untrapped. So definitely some energy of the light wave will be lost over here, and we need to have an efficient coupler to feed this light signal efficiently to the optical fiber. So coupler is a very important component in the fiber optic communication system as well as in the wireless communication system, because this coupler will feed the signal efficiently to the information channel. Now we talk about the information channel. We have already discussed the information channel in the previous class. Information channel is the medium or the path between the transmitter and the receiver. The electromagnetic signal travels from the transmitter towards the receiver in this information channel. And there are two types of the information channel: guided information channel and unguided information channel. We know that the only example of the unguided information channel is the atmosphere, that is the air, which is known as the wireless information channel as well. And this wireless information channel is utilized by different types of wireless communication systems. There are so many examples of the guided information channel. We use guided information channel in case of fiber optic communication system, and the guided information channel in case of fiber optic communication system is the optical fiber. Let us talk about the structure of the optical fiber. Optical fiber is either made of glass, that is silicon dioxide, or transparent plastic. So there are two cylinders in an optical fiber. The inner cylinder of the optical fiber is known as core of the optical fiber, and the outer cylinder is known as the cladding of the fiber. So the light signal travels inside the core of the optical fiber. Whenever the signal travels in the information channel from one place to another place, the attenuation of the signals take place. The energy of the signal reduces with respect to the distance traveled by the signal. This phenomena is known as attenuation. And we need to take care of the attenuation as well. We need to take care of the attenuation because there is a term which is known as sensitivity of the receiver. What is sensitivity of the receiver? Sensitivity is basically the minimum level of the energy of the signal which is recognized by the receiver, which is detected by the receiver, or which is received by the receiver. So we need to maintain a proper energy level of the electrical signal. We do it with the help of amplifiers or repeaters. We will use amplifier in the information channel to amplify the signal. In case of fiber optic communication system, we will use optical amplifiers. Anyhow, optical fiber does not attenuate the signal too much, so less number of amplifiers will be required in case of fiber optic communication system as compared to the traditional electronic communication system. We consider these minor blocks once again. These are the minor blocks of a communication system. We have discussed the function of the information channel, which is medium. We go ahead to the receiver now. And there are 5 minor blocks inside the receiver of a communication system. You see, there is a minor block for the coupler, there is a minor block for the detector, there is a minor block for the amplifier, there is a minor block for the signal processing, and there is a minor block for the message output. So the final block is the block for the message output. Let us talk about the functions of these minor blocks which are located inside the receiver. We talk about the coupler. Now the function of the coupler is to receive the signal from the information channel now. This coupler needs to receive the signal efficiently from the information channel. As an example, I consider the coupler in a wireless communication system. In a wireless communication system, we radiate the energy to the information channel with the help of a transmitting antenna. This energy travels from the transmitter to the receiver, and this signal is received by the receiving antenna on the receiving side. So the receiving antenna of a wireless communication system is an example of coupler which receives the information from the information channel. So the function of the coupler is to receive the information efficiently from the information channel. Then we talk about the next block inside the receiver, that is detector. So what is the function of a detector in electronic communication system? In the electronic communication system, this detector is also known as demodulator. So this demodulator or detector blocks the high frequency of the signal. You see, there are 2 frequencies in the modulated signal: the carrier of a very high frequency and then the signal, the electrical signal. The information is in the low frequency electrical signal. There is no information in the carrier. So we need to block the carrier because it does not contain information. So we need to block the radio frequency of the signal, and this is the function of the detector. In fiber optic communication system, this detector is known as photodetector, which is basically a photodiode. What we need to do in the fiber optic communication system, we need to convert the light signal into the electrical signal now. The light signal is to be converted into the electrical signal, and this is the function of the photodetector or a photodiode. So, detector in case of the fiber optic communication system is a photodiode which will convert the light signal into the electrical signal. Then we talk about the next minor block, which is the block for the amplifier. We know the function of the amplifier. So the amplifier amplifies the signal, including noise. We know that whenever we transmit information with the help of a communication system from one place to another place, some unwanted frequencies are added to the signals. And these unwanted frequencies are known as noise. So the signal so far contains noise. So this block amplifies the electrical signal along with the noise. Then we talk about, the next minor block, which is for the signal processor. What is the function of the signal processor? It filters the signal. What does it mean? It means that the signal processor blocks all the unwanted frequencies in the signal. It means that it blocks the noise. It means that the signal processor improves the signal to noise ratio. It improves SNR. So it filters the signal. In a digital communication system, the signal processor contains a circuit that is known as decision-making circuit. This decision-making circuit inside the signal processor decides whether bit 1 is received in a particular time slot or a bit 0 is received. And there will be bit error rate. But if we talk about a quality communication system, the bit error rate should be as minimum as possible. So anyhow, this is the function of the signal processor. It filters the signal, it blocks the noise, it blocks all the unwanted frequencies of the signal. Then we talk about, the last or the final minor block of this communication system, which is the message output. Once again, it's a transducer. And what is the function of this transducer? The function of this transducer is to convert the electrical signal into non-electrical signal now. If it is an audio signal, then the transducer will be a loudspeaker. And we know the function of the loudspeaker. The loudspeaker converts the electrical signal into sound wave. If it is a video signal, then definitely this transducer will be in the form of a screen, LCD screen, right? CRT, cathode ray tube. And this transducer will convert the electrical signal into images and so on. So thank you so much